Hello everyone. Good morning, good evening, good night, and welcome. My name is Natalia Jorquera from Chile, and I'm the chair of the Seismic Subcommittee of the International Scientific Committee on Earth and Architectural Heritage, ISCEAH, of ICOMOS, a committee that is dedicated to the study, conservation, and promotion of Earth and architectural heritage around the world. And we are organizing this series of webinars. And today we are pleased to launch the first webinar with Adrià Sanchez, that is here, who is from Spain, but he lives in Mexico. And this will be a series of 4 lectures aimed at disseminating recent researches about seismic behavior, vulnerability assessment, and retrofitting strategies for historic earthen structures. This initiative responds to the fact that despite significant researches have been made in recent years, many misconceptions about the seismic behavior of earthen structures still persist, and inappropriate intervention remain common, unfortunately. So we begin today with a lecture titled How to Assess the Seismic Vulnerability of Adobe Buildings, comparing different methods in Mexican Vernacular Adobe Buildings, and it will be presented by Adrià Sanchez. Adrià Sanchez is a postdoctoral researcher, lecturer, and science communicator of the Faculty of Civil Engineering at the Universidad Michoacana de San Nicolás de Hidalgo in Mexico. He's a technical architect with a PhD in architecture, and his research focuses on vernacular architecture, traditional building materials, seismic vulnerability, and the circular economy. He has published in high-impact scientific journals and has been involved in several international research projects and academic collaboration. He's also part of ISCEAH committee. His work addresses the documentation, analysis, and conservation of vernacular and traditional architecture. In addition, he's actively engaged in science communication and directed a documentary, Sirangua, which explored the vernacular architecture of Michoacán in Mexico. This lecture will last approximately 30 to 40 minutes, followed by around 30 minutes for questions and discussion. And this session is being recorded and will be available later on the ICOMOS YouTube channel if you want to disseminate it. And in the meantime that Adrià is speaking, you can leave your question in the chat of the Zoom. So Adrià, the microphone is yours.
Thank you so much, Natalia. It is an honor and a pleasure to be here with all of you. I hope you can hear me right.
Yes.
Okay. Thank you, Natalia. As I said, I feel really honored to be here and to present part of my research. I hope it's useful and can be interesting for the public here. First, I want to say that maybe the title can be like really directed or related with the Mexican vernacular heritage, but it is not the situation, because I think that all these things that we will see today are common to all the world. We all have the same issues with earthen heritage. We are losing it. We have really bad problems preserving it, and many regions of the world have seismic risk. So it is really important to know how we can assess this risk and the vulnerability of these buildings. So when we talk about earthen heritage, we know that we have many techniques like Bajareker, Bottle and Dove, we have COB, we have rammed earth, but Adobe is like one of the most common techniques in all over the world, this masonry technique. And in Mexico, it is the most famous or the most common earthen technique that we have, and I will show you some data that demonstrates it, and also the social recognition of Adobe is really particular in Mexico. Like almost all the population of the country identifies with Adobe or recognizes it at least. So I will start with the bad things, and then I will try to give a positive note. But let's start with the common situation. As I say, this is a global situation. This is not a thing from Mexico, but the situation is that we are losing our earthen heritage, and particularly Adobe heritage in these places that have Adobe architectures. So here we can see some powerful images that show us how we are losing and this common picture of abandoned buildings. But this abandonment of earthen architecture and earthen construction does not respond to only one property or only one problem or specific situation, but it's multifactorial, as we will see. So let's give a picture of what's happening. Here we have some graphics from the National Institute of Statistics and Demographics of Mexico, the INEGI. I hope to have more recent data that it's going to be published very soon. The census from 2025, that it's not already published. But as we can see, in the recent like 20 years, we are losing. We are losing all the Adobe and the traditional materials construction by industrial materials. As I say, this is a global situation. All the countries have experienced this loss of earthen, or not only earthen, we are also losing our wooden heritage and construction cultures, the same with stone. But in the case of Mexico, it is like really focused on Adobe, because Adobe, like a great part of all the Mexican cities and territory was made with Adobe. This is the most common technique, as I will show you later. So in 2000, we had like almost a 10% of all the buildings in the country made with Adobe, and we see that in 2020, it is like 4%, and probably with the new statistics, it will be lower. And as I say, this is not only by one factor. There are a lot of factors that affect this loss of earthen construction. Okay, here. Another important thing. This is a map from the state of Morelos, that is one of the 31 or 32 states in Mexico, and it is a chloropletic map. It shows like the parts that have more intense color have more of that thing. So we can see that the earthen architecture is located also in the less dense populated places, like it's associated with rural to the rural world, and it is also related with the lowest economic incomes. So in Mexico and in many other countries, like the earthen architecture is associated by the general population, not all people, but mostly with poverty, with rural communities, with indigenous communities. So we have this situation that it's really sad, but people don't want anymore to build with earth. And it is also accelerated by migration. It happens a lot that in Mexico, young people goes to United States to have a better living, to earn more money, and when they return, they don't want to build an Adobe home. They want to build with industrial materials, like very influenced by these United States type of dwellings. So we are losing the heritage, and also we have these bad interventions that are really important for the seismic part. So here in Morelia, where I live and I work in the Universidad Michoacana de San Nicolás de Hidalgo, we try to make a lot of workshops, classes, lectures, activities with earthen materials. It's something that we love, and we try to show the young students all the possibilities they can have. And in the last, like, I would say 6 to 7 years, we have been conducting a lot of workshops and lectures about earthen architecture. And after these lectures, we always conduct some encuestas, some forms to the students to see which is the knowledge, the previous knowledge that they have related to earthen architecture. And what we see is that 99% of the students, I think we had in total 184, and I need to actualize all this information. 99% of the students in Mexico and some from Colombia, because we have some international students in these research summers, they all identify Adobe. And not all of them identify, for example, the compressed earth blocks, the ramet earth, the wattle and daub, or bajareque, the super Adobe or Earthback, but all of them identify Adobe. And this is cultural. As I say, in the imagination or in the general thoughts of Mexican society, everybody knows Adobe. And if you see all films, even Western films from United States, or films from the Siglo de Oro in México, no, not Siglo de Oro, la década de oro of Mexican cinema, you can see these Adobe structures. It's something cultural from this country, and as I say all the time, from many other countries. So this is like the typical stereotype of Adobe dwelling in Mexico that many students, many young people, and also a lot of old people identifies with. So now I'm going to give like this positive note. As I said, all of this that we're saying is quite depressing, but I'm going to show you this part of a documentary. I hope you can hear it well.
Pero así estoy viviendo, tranquilo. No, pues así está bien, pura madera, está bueno así, está bien así.
Está maciza la madera.
Sí se puede, pues.
Madera antigua, durante el tiempo. Eso sí no se ha cambiado y ni se ha picado, mire esa madera. No. Ya ven que ahorita la madera ya no tiene pues duración porque sacan toda la resina. Y esta madera está llena.
Le sacan la resina, entonces ya la madera ya no sirve.
No lo protege la madera, ya no protege. Y esta madera nunca se ha polillado. Y esta casa cuando hace calor está fresquecita.
Tranquilo, no hace frío, no hace calor. Una casa de muy tranquilo. Y sí me gusta, porque mi papá aquí me donó. Y hasta que no me muero, salgo.
Okay. This is part of this documentary, Shirangua, that we made here in Michoacan to document and put into perspective and value our heritage in the state of Michoacan. And this fragment was part of the section that was related to Adobe building. They were talking a lot about the wood and the wooden beams that has this house, but the important thing here is that this old couple who inhabits an Adobe building, I think that the last sentence is so powerful. Like, until I die, I will leave this home. It's not cold, it's not hot. Like, sometimes we see like the bad misconception and perception of Adobe by a great part of the population, but the people who has like these buildings, they really value it, and this is the important part. So now we will change and we will go on the seismic response or the seismic behavior of a Adobe building. So what has happened? This was a communicate by ICOMOS after the earthquake in Morocco. I don't remember the exact year, I'm sorry. But what happened is that from ICOMOS, they had to make this statement because the mass media, television, radio, social media, they tried to give the fault of the results of the earthquake to the earthen heritage or the earthen constructions, and this was not right. And this is the same thing that happened in Mexico in 2017. In 2017, the country had two major earthquakes, one with the epicenter in Puebla and the other in Chiapas. And the two earthquakes had a lot of impact in the country, a lot of casualties and a lot of loss of buildings. And what happened after this earthquake is that most people say that the fault was on building on Adobe construction. But as we can see in these pictures, these buildings were not completely earthen or Adobe buildings. They had a lot of bad interventions. We can see modern materials, we can see concrete, like here we can see clearly the concrete column. We can see the roofing structures, also incorporating other type of industrial materials. So these Adobe buildings were not well designed and were too modified after decades and after the growth of the population. Mexico is a highly seismic country. It's divided into different like seismic regions, and the center of the country and the Pacific coast is the part that is more prone to these events. So here, what I want to say is two things. First, that the bad response of earthen buildings and Adobe buildings is not related only by the material and the construction system. It's more related on how we are building them and how are we modifying. And here I want to make like a little criticism, because I think we all, probably all the people that it's attending this webinar, we all are totally in love with earthen heritage. And sometimes we have a really romantic vision that everything that is made with earth is beautiful and it's nice. But we need to understand that yes, earth is magnificent. I love it. But there are bad earthen buildings. Like in all of the periods of humanity, you have wonderful buildings and you have, sorry for the expression, shitty buildings that are really bad built with bad design. And we need like to think like this, that if something is made with earth, it will not be good or bad to an earthquake or other type of disaster. It depends on the quality of the design and the building process. And that's what happens here. And that's why we have like this concept of culturas sísmicas or culturas constructivas, what would be translated to seismic cultures or constructive cultures. And people, humanity has learned how to build these buildings, has some strategies, and it's not related to the Adobe block or the material. It's related on all the envelope, all the building, all the strategies, the connection between the different construction systems. This is like the seismic resistant part. Because sometimes I hear like some expressions or some opinions I even have heard like Adobe is seismic resistant, or I have heard it a lot here in Latin America. El Adobe es sismo resistente, but I don't agree at all, because what we mean by Adobe, a block, a wall, maybe the building can be sismo resistente or seismic resistant, but Adobe, if we enter like in all the theoretical conception, it is only a block. A block is not seismic resistant per se. You need to have a complete system. And in this sense, in the scientific literature of earthen architecture, this is a really interesting article that we published in 2024, and we did a bibliometric analysis of earthen construction literature, scientific literature. And we saw that we have like different clusters on how we are from the academia studying the earthen architecture. We see that we have a cluster more related to characterization and material properties, other more related to sustainability with construction technology, sustainable, thermal performance, life cycle assessment, thermal conductivity. And we have a cluster that is more related to heritage, where we see conservation, cultural heritage, archaeology. And then I have marked here like a great part of this scientific and academic literature and all these efforts are on the seismic part, because earthquakes are one of the most important and bad disasters that we can have, and they have a lot of not only material impact but also social impact, and an earthquake has a deep full impact on the population. And then in the literature we can see all these things that I was saying about like the seismic cultures or the seismic resistant practices that vernacular architecture has, like an Adobe block has not a lot of mechanical resistance, especially for traction resistance. So it is important to have complementary strategies to make these buildings more resilient. So now I will show you part of this research that we developed here in Mexico. I will show you first the study cases. We had like different populations. We had two populations in the state of Michoacán, Santa Cruz de Morelos, that is more like a rural study case, and Ario de Rosales, more like a urban study case. And then we had also San Pablo Etla in Oaxaca and Copainala in Chiapas. We had a lot of help from students from the Delfin and the Delfin program of summer research days that they came to Morelia, and they could go back to their communities and make these architectural surveys and documentation. So our idea was to map and to analyze the seismic vulnerability of Adobe buildings in different contexts, because we need to have like this complete picture of Adobe buildings. So as I said, we have like some study cases that are more related to a urban scheme, like small cities. And then we have like these rural populations, these study cases, where like the infrastructure, climate, and everything is like really different. Here we have a dwelling in San Pablo Etla, in Oaxaca, and here we can see one in Ario de Rosales. So we document all of this. We know that each of these houses have like different typologies, morphologies, the combination with other construction materials and systems, like we have the stone foundations, the wooden roofing structures, and all of that. And then even in the same study cases, we have like completely different buildings. For example, regarding the state of conservation, we can see this Adobe building in Ario de Rosales that it's almost falling off. And then we have like these historical big houses from the colonial period that have dimensions, proportions, and we have like really different. You can compare this with this, like a really small and simple Adobe house, but all of them are made of Adobe. And what we are trying to do is to characterize and analyze the seismic response of these buildings. So how we do it? What we did in this research was to compare different methods to assess the seismic vulnerability. I will make a brief introduction, but seismic vulnerability has been widely studied. The first like vulnerability index methods were developed in Italy, and in recent years a lot of methods have appeared and have been studied and replicated in scientific literature. So we selected 5 different methods. The first is GNDT, the first one that was made in Italy. Then we had the method from Formisano that it's really interesting because it adds the urban aggregate and the urban aspects to all of this. The Vicente method, that it was really interesting, and the Ortega method that was specifically designed for vernacular architecture. And what we do with these methods is to obtain a vulnerability index. And this vulnerability index is normalized between 0 and 100, and it says how much a building is vulnerable to an earthquake. So what these methods do is to conduct like surveys and fieldwork to obtain some parameters. So in total, we selected 21 parameters that are common or specific to some of to these methods. So here I will show you some examples. Like for example, these 10 parameters that are from the Ortega method. So we have the wall slenderness, that is the relation between the height and the width of the walls. As we know, if a wall is too slender, it probably will, definitely will have a worse response to earthquakes. Then the maximum wall span, like the distance between structural systems, they can be columns or they can be walls. The type of material, the wall-to-wall connections, the horizontal diaphragms, the roof truss, the wall openings. If we have 2 openings in a wall, we have less resistant material, so it's worse. The number of floors, the previous structural damage or the state of conservation that you can see here. And in total, there were 21. So what we did, so we did a lot of field work with architectural drawings, but mainly we worked with technical sheets that contained information to classify these 21 parameters. And for the urban parameters, we have the help of drone surveying, but mostly it was like a lot of surveying. It was really nice. As you can see, we all had these COVID masks because this was, if I'm not wrong, in 2021. So I had a lot of help from students because we were still in the lockdown. And when I told them we can go outside to do some fieldwork, they were crazy and so happy to come to these communities. So it was a really nice process. Like all the people in these communities were so kind. Let us enter to their Adobe homes, and also there were a lot of qualitative data. That's why we did this documentary, Shirangwa, that I encourage you to see it. But regarding like this technical information, so what we did is a lot of fieldwork and a lot of processing of this information by the technical sheets and the architectural drawings. And here is where we can see, like, I think the most interesting part about the seismic vulnerability of these buildings, because you can see the variations between buildings, communities, construction cultures, and it's really interesting because you have to see like all the things of the building, like the connection with the foundations, the state of conservation, the roof thrust, the geometry, the morphology, the dimensions, this slenderness and ratios and all of that. And you can see how Adobe buildings can be really, really different from not only from one region to another, but in the same city or village, you can see a lot of variations, and that's what I was saying before. That only because one thing is built with Adobe, it is not good or well constructed. And you can see wonderful buildings, and you can see buildings that have really bad maintenance, that were not well designed, and these are the ones that will have a worse vulnerability. So here there are some examples, and the point of doing this comparison with the different methods was to compare the suitability of these methods for earthen heritage, because these methods, like GNDT, Formisano, and Vicente, are methods designed for all buildings, not only earthen buildings. And earthen buildings have different parameters, have different properties. As I say, the mechanical resistance of Adobe or even rammed earth or cob is not so high as industrial materials are ceramic bricks, are concrete, of course. It's not the same. So you need to evaluate earthen buildings with different parameters, or not only the parameters can be the same, but the sensibility, like the way you assess. And the Ortega method was the only one designed for vernacular architecture, specifically in Portugal, for stone, mainly stone and dry stone buildings, but also earthen buildings, a lot of rammed earth. So here we can see like these methods from Ortega, from Vicente, can assess very differently, for example, the wall slenderness. In the method of Vicente, we have class A, B, C, and D. And we can see that most of the buildings have B and C vulnerability classes. While in SVIva and SAVAS, that are the two methods made by Ortega, most of the buildings have A class, that it's like the best, like these buildings are less vulnerable. And why? Because you have more tolerance, because these methods are designed to vernacular buildings, and vernacular buildings normally have different slenderness ratios. And you can also compare like the maximum, for example, this parameter, maximal wall span, between like the different study cases. So you can see that there are some study cases that have more seismic cultures than the others, that have a shorter wall spans. That did something interesting. And you can find like a lot of interesting things, like for example the wall openings. We can see these really small openings, and only like the door in the entrance, while you can see in other communities that they have with the time they have done a lot of interventions, and they have made like new windows, new doors, new entrances to the building. It's not good for seismic response. We also related all of this with also the material characterization in the materials, because we work at the materials laboratory in the Faculty of Civil Engineering, and we wanted to correlate all the seismic response with the material characterization of some of these samples. So I don't want to be very technical with the results. I think like the important part of this webinar or the conclusion is more related to these seismic cultures, like how there are some strategies to build more resistant buildings. But I will show you some of the results of this research that are also published. And we can see, for example, that for three of these methods, GNDT, Vicente, and SVIva, give us a vulnerability index. And what we found, is that the methods designed for common buildings or all type of buildings gave us like really low vulnerability index values. Like they say, these buildings have really low vulnerability, while SVIva, the one that is designed by for vernacular architecture, gave us higher vulnerability indexes, like between 20, 40, and all of that. And this is more accurate. We think that this is closer to the real behavior of earthen buildings. What happens is that the design of the traditional vulnerability index methods they don't relate good with earthen buildings, because earthen buildings have like more conservative properties regarding, for example, the wall spans, the slenderness, the openings. Like the material, as I say, the Adobe block has not the same resistance as concrete. Therefore, you have to rely on these seismic cultures and these strategies to improve their resilience. And in the case of SAVAS, we obtain the same, but for the load factors. And the load factors also look like really interesting. So what we do with these methods, what is the result that we obtain? What we do is that we can estimate damages based on the information that we collect with these technical sheets and with the fieldwork. Like we map the vulnerability of these study cases, we can compare them, and we can see how they will respond to some seismic events. So here I will show you the mean damage rate, that it's the symbol, and we have 1, 2, 3, 4, or 5, and 5 is the total collapse of the structure. Okay, like these things that we have seen in Morelos, in Chiapas, in Oaxaca, with the 2017 earthquakes. Another interesting thing is that we can compare the vulnerability index between the different study cases. And we can see that, for example, Copainalá or San Pablo Erla have higher vulnerability than Ario de Rosales or Santa Cruz de Morelos in Michoacán. And we can start to estimate the damages. And we can see that the behavior of these vulnerability curves is really different depending on the method. We have GNDT, that it's like the classic method, Vicente, SVIva, and SAVAS. And they gave us the damage depending on the seismic intensity. As probably you will know, we have two ways to classify earthquakes: by magnitude or by intensity. And intensity is more related to the damages and the affectation on site, and magnitude is related to the energy that is like liberated in the epicenter of these earthquakes. Okay, so we can see which will be like the response of these buildings in terms of damage of these buildings. And we can see that SVIva and SAVAS are more conservative, but I think it is okay, and it is more related to the empirical knowledge that we have seen and that we know that we have after these events in Mexico. So, for example, we can go here and say, if we have a seismic intensity of 8, that a lot of these recent major events have had like this type of intensities, so probably we will have a mean damage rate in all the buildings of more than 3. And if we see 3 is like is this, we have like some major damages that require some major interventions in these buildings. Remember that 5 is collapse. And then we also obtain the fragility curves that it's similar, but they are talking about probability of damage in function of like the seismic intensity, or in the case of SAVAS, in peak ground acceleration. That peak ground acceleration is like the acceleration of these events. And we have data from historical earthquakes saying that this had this peak ground acceleration always in function of gravity. So it's the same. We go here and we say we have a peak ground acceleration of 0.4. So almost all the buildings will have a damage to grade, and 80% would have like a mean damage of 3, of level 3, and only, sorry, I'm losing, and only about 15-20% of the buildings would collapse with this peak ground acceleration, and the same for seismic intensity. And our conclusions from the research, the doctoral thesis, and the paper that it's published, is that SAVAS and SVIva, these methods created by Javier Ortega specifically for vernacular architecture, are the most adequate to study and assess the seismic vulnerability of earthen buildings. And we also can see the number of casualties and people who would become homeless. So these methods are giving us a lot of data and a lot of valuable information to assess, like the consequences of earthquakes in these localities. And well, I don't want to be very technical with the presentation, but I think that one of the most important parts of these methods and this research work is to compare like the different study cases and see how some of these seismic resistant strategies that we can see on the field work and all of that we were saying are really important to know how resilient or how can these buildings resist these events. So and this is in specifically what I was saying, that I think one of the most valuable outcomes of this research was that we have like these relationships, for example, from the height of the buildings, the thickness, the slenderness, the wall connections, the diaphragm, the roofing systems. We have the classification of all these different localities. Here you can see what I say, like a traditional building with small windows, small door, and here we can see like new interventions, and we have a new door. So this is not good for seismic parameters. Also, some of the most common interventions that I think you can see in all the world is the substitution of the traditional roofing finishings, like the ceramic tiles, for these metallic sheets. That in terms of seismic behavior, they are not so important, but in terms of comfort, thermal comfort, and all of that we saw in this short video, they are indeed really, really important. And it's like a transformation of the original system that it's not really, really good for a lot of purposes. And we also related all of this with the material characterization. We have a lot of data, but here we have like some of the outcomes of the research. We have these articles and even some more. So if you are interested, I can provide you like the files and all this information. But as I say, I hope that this webinar has been interesting for you. It has been like the first of the series by the Seismic Chair Committee. And I hope that it has been useful. Also, if you have questions. But first of all, thank you so much for your attention. And I leave my email if you want to contact me. And thank you again, Natalia, for inviting me, and all the public that we have in this session for your attendance.
So thank you very much, Adrià. It was very, very interesting and we have more than 30 people connected. So I think it's very successful this day of the week and at this time. So now we are going to open the microphone for questions or comments. If you want, you can make the question in Spanish, because I think most of the people is Spanish speaker. Or comments. In the meantime, you think of, this Héctor Esteban is want to ask something or to say something? Héctor Esteban?
Thank you. Bueno, igual puedo hablar en español. Me parece más fácil. Bueno, primero que nada, muchas gracias. ¿Sí me escuchan?
Sí.
Muchas gracias, fue muy, muy clara y es sobre todo muy interesante cómo se hace esta comparación entre diferentes métodos para evaluar la vulnerabilidad. Dentro de los elementos que se evalúan, vi que viene, por ejemplo, las conexiones, wall-to-wall connections. Entonces, mi primera pregunta sería como, si estas conexiones se evalúan como positivas o negativas, y tal vez yendo un poco más allá, es cómo se incorpora en estas evaluaciones el criterio de los expertos. Porque me parece que, por ejemplo, en estos casos hay que ir mucho más allá de decir es positivo o negativo, sino que hay que ver puntualmente en el contexto que existe cómo impacta en respuesta a un temblor. Esto es, por ejemplo, con una experiencia que tuvimos trabajando con Miyamoto Internacional. Fuimos a dar apoyo de ingeniería frente al temblor en 2022 como sustituto de host. Y dando este soporte nos dimos cuenta dentro de las rapid assessments, los primeros assessments que se hicieron de todas de una parte significativa de las construcciones, que la mayoría de las construcciones que evitaron que se cayeran los techos es porque las conexiones entre muro a muro eran flexibles. Entonces, por lo menos para mí fue un caso particular porque generalmente se considera como positivo que haya una conexión rígida entre conexiones. Entonces, bueno, ya conciso cómo se toma dentro de estas evaluaciones que se tomaron en cuenta, cómo se toma en cuenta el criterio de la expertise al momento de hacer la evaluación, más allá de decir de manera cuantitativa, sino tomando el aspecto cualitativo. Espero que haya sido... ¿Es clara mi pregunta, mis preguntas?
Sí, muy claro, Héctor. Bueno, muchas gracias, antes que nada. También están preguntando si se puede responder en inglés, pero voy a responder primero en español y luego trato de hacer una traducción. De hecho, pues uno siempre se explica mucho mejor en su lengua materna y a veces como que es un poquito complicado hacer el webinar en inglés, a veces me pierdo y no encuentro las palabras. Tu pregunta es súper pertinente, muy interesante y también súper específica, por algo que te voy a comentar ahora. Lo primero, muchas veces lo que tratamos de hacer nosotros es documentar y tenemos también el apoyo de la fotografía, del dron, pero a veces el dron ni hace tanta falta. Pero con la fotografía, al final lo que nos evita es tener que regresar y volver a tomar los datos. Entonces, hay varios parámetros que se pueden tomar y marcar en la ficha en campo, pero muchos ya es luego a partir del procesado de los datos, porque digamos es sacar relaciones. Por ejemplo, al final el parámetro de la esbeltez realmente lo calculas una vez ya no estás en campo, porque no vas a sacar la calculadora, porque al final en campo no tiene sentido, luego calculas altura entre grosor de los muros y así pasa con muchos. Y este, por ejemplo, es uno más. Entonces, esto nos permite también, a la hora de hacer el análisis y el procesado de los datos, poder tener, digamos, el apoyo de los expertos, que es algo que no dije en su momento, pero sí fue muy, muy importante. Todo esto se trabajó también con Javier Ortega como parte de la tesis, que él era el codirector. Entonces, pues sí, se llegó a un consenso para cómo evaluar ciertos parámetros. ¿Por qué? Porque estos métodos mayormente están diseñados, como decíamos, para todo tipo de edificaciones, no únicamente para edificaciones de tierra. Entonces hay parámetros que no tienen por qué ser tan importantes, o más que importantes, que no pueden tener tanto sentido, porque hasta el día de hoy no tenemos un método que yo conozca, igual hay alguno, diseñado específicamente para adobe o para construcciones con tierra. Más que nada porque también hay muchos tipos de construcciones con tierra con características muy distintas. O sea, solo hay que ver el bajareque, que al final la estructura es más de bambú o de madera que otra cosa. Entonces, en el caso del Wall-to-Wall Connections, es muy interesante tu pregunta, porque este partía de la metodología de Ortega, que como decía era más edificios de piedra, piedra seca, tapia, y ahí digamos que en los edificios de mampostería de piedra sí sueles tener las cadenas de ángulo, que puedes tener sillares, esto se ve mucho en edificios históricos, en los centros históricos de México, en los que siempre hay un refuerzo estructural en las esquinas. En cambio, en lo que es edificios de adobe, esto no pasa tanto. Al final siempre es un cuatrapeo, o sea, sí, digamos que como las hiladas de ladrilla o de adobe, pero no suele haber un refuerzo vertical en esas esquinas. Es muy raro. En algunas localidades que son muy sísmicas puede haber algún refuerzo de madera. Entonces, ¿en qué nos basamos? Hay un micro abierto por ahí. No sé si alguien lo puede ver.
I think it's Alex Lim from Arizona that has the microphone open, but I don't know how to. Yes.
Entonces, lo que te comentaba, Héctor, es que al final nos basamos un poquito en la calidad de los encuentros y lo hicimos de este modo, viendo un poquito el mantenimiento de estas conexiones y la calidad en sí de los bloques de Adobe, porque realmente este parámetro no era tan fácil de aplicar como otros, que al final es hacer una fórmula o incluso el estado de conservación, que también llega a ser cualitativo, pero pues si con una buena inspección y todo eso, sí puedes decir si es una clase A, B, C o D. Espero haber respondido tu pregunta. Y la respondemos en inglés también, Natalia.
Yes, I think we can also answer in English, but more briefly, if it's possible. We can say it was Nicola, Nikos, that
Okay.
Hector asked for the importance of the connections wall to wall. No, that was more or less the answer. So, yeah.
The question that Hector did is how we assess it, like the wall-to-wall connections. And I answered him that these wall-to-wall connections was more related to other type of buildings, mainly stone buildings that have like these more like robust solutions in the corners of these buildings. So did based on the quality of the connections on the Adobe walls, because it's always the same. Like you have like the Adobe connection that it's like the same of brick construction. So we assessed it on this quality of the encounter and the blocks.
Yes, I just to what I found most important about the question. Sorry, just really fast. It's about not specifically about the connections. This was just like an example, but how is the expertise judgment it's taken into account? Not precisely assessing just the type of connection as positive or negative, but how in a specific context it's included the expertise judgment.
Yeah. I forgot to say a really important thing. I'm sorry. That it's like all these methods have their own guidelines. So you can assess, you can go to fieldwork and you have like your guideline and you can see, and it's class A, B, C, or D, because they all always evaluate with different vulnerability classes, A the best and D the worst. So you have this, but it's really quantitative, but there are also some qualitative, like for example, the state of conservation. You always have to make some judgments, but you rely on the expertise of you, your partners, your colleagues, and other experts that you can consult after the fieldwork is done. As I say, like in fieldwork, we take some data, but we process them later.
Thank you, Hector. Thank you, Adrià. We have another question from Chile, from Hugo Pereira. He asked if are there earth building codes in Mexico? Si hay normativas en México. And then another question, what do you think about super adobe technique? That's another thing.
Okay. Yeah, there are not yet building codes for earthen construction. There is only one standard for compressed earth blocks, and it's compressed earth blocks stabilized with lime or cement, but it's only for the stabilization. But no, there are not yet, and I think this is work we have to do. So it will be like really important in the near future. There are some initiatives, I think, but I'm not sure. And about Super Adobe, Super Adobe is like the technique that I'm less familiar with. Like I have worked more with Adobe and Bajareque here in Mexico. But I have to say that I work on the research and academic part. I'm not architect. I don't build anything. So I think regarding like the seismic behavior, probably Super Adobe or Earthback is one of the best techniques.
Thank you, Adrià. I was going to say that in Chile we have a code, a building code for the intervention of earthen architectural heritage. That is from 2013, and now we are going to upgrade it because it has passed 13 years from the promulgation of this code. And also in Peru, we have they have a building code for earthen heritage and also for earthen new constructions. So is there another question? Yes, Inta Gabriel Hernandez Contreras. How often do you hold earthen construction workshops in Mexico? I'd love to participate in one, please. Así, los talleres de construcción con tierra en México, ¿cada cuánto los realizas?
Okay, so I will make some announcements. Right now we have a really interesting project with Inbrau grassroots program, and we are just working this year on the certain construction workshops. We will have one in July. We always publish them, and they are free. But you have to come here to Morelia, to Universidad Michoacana de San Nicolás de Hidalgo. And how often, it depends. But this year we have like some resources from the project, and we have done a lot of them. And I also recommend you to see like the work and the social media of Escuela Autónoma de Mujeres, that it's an association from Mexico that works mainly with women, and we collaborate a lot of them to do these earthen workshops. Last year we did one on earthen finishings, Japanese style, and another on COP. And now we have done we will do like these pedagogical suitcases from Craterra, and we are starting to do this also with our students and the university. So you can write me by email or anything, and I can give you the information. And thank you also for your interest.
Okay, thank you, Adrià. Is there another question or comment? There's Sandro Canova that says, how do you submit a proposal for a talk? So that will be interesting. If some of the people that is here wanted to present a research, you just have to write to me. We have planned 4 lectures this year, but if we have more people interested, we can make more lectures. It's not so difficult to organize this. So, is there another question or comment? ¿Usted va a participar el próximo CIACOT en España, Adrià?
No, me gustaría mucho. I would love it, but I didn't send anything, and the calendar was really difficult this year. But I hope for the next one.
I'm going to participate, Sophie. Voy a participar, and I'm going to be responsible of together with another 3 colleagues, of a restoration workshop in an Adobe building, Adobe building. So, is there another comments or questions? ¿Algunas preguntas o comentarios? No? So I'm going to make some comments of your presentation. I like very much that you started your presentation saying that you put this case study from Mexico, but you said at the beginning that is this a problem of most of the heritage around the world. And I agree with that. We have the same problems in Chile, in Mexico, in Ecuador, and in all of the countries that are under seismic risk and have earthen heritage. And as you said, this is a multifactorial factors. Most of the times, in the news, in the television, when there is an earthquake, we said, this is because of the Adobe. It's a fault of the Adobe. And as you showed in your presentation, most of the time are the bad interventions and the abandonment and the bad state of conservation, the really the faults of the damages. That's one comment. The other comment I think is very, very important is that, as you said, it's not good or bad because it's an earthen structure or an Adobe structures. In all the materials and in all the techniques, we have bad or well-designed and built buildings. So we have always to analyze case by case. And as you said, as I'm in love with the Adobe and earthen heritage, we have to admit that there are some bad built or design buildings. So this is a very, very important thing. And you showed the earthquake in Morocco, and there we have a lot of examples of bad interventions and in earthen construction, and most of the damages were concentrated in these buildings, but there were a lot of traditional buildings, earthen buildings, well constructed that didn't have any damages. So that's an important example to study. And one last thing I think that is very, very important, that the comparison of the method you showed, I think that one of the most important things that they are all geometrical parameters that are very easy to identify in a field work, you know, like the slenderness, the distance between the span. And so they are all, I mean, you don't need an engineering or a sophisticated calculation to understand how vulnerable is the building or not, because they are all geometrical parameters that you can simply identify. So I think that's a very good contribution of these parameters. Even some people, some inhabitants, some communities can make this assessment with these parameters if you teach them how to do it, how to measure the length of the wall and the height of the wall. So I think that's very, very important. And I had one question that it is from one of your last slides, that is about the laboratory test you made with some kind of earth, I think. And I wanted to know how important are these values of mechanical resistance, I think, of the earth in the seismic performance, in the global seismic performance, because I think, but I think, it's my opinion, that it's not very, very important the resistance of a block, but most of all the geometrical parameters, the connections, and all these other factors. So I would like to know which are the results of your laboratory tests in the materials.
I agree totally with you,
Mhm.
because, for example, we have seen like in the presentation that we take into account, including like all the vulnerability index methods, 21 parameters, and only one is related to the mechanical resistance of the material. I wanted to include too many things in the presentation, so maybe I should have leave like this mechanical characterization, but it's something that we did complementary, but also with other purposes. But one interesting thing is that we took some samples from Jojutla, that was a locality in Morelos that was so damaged and so affected by the 2017 earthquake, and we compared the samples with the samples in like other study cases that did not have any seismic affectation. And what we saw is that the samples from Jojutla had like a reduction of the mechanical values by 50-60%. Like it's obvious, like if you suffer an earthquake, your resistance is lower, but it has an important affectation, because sometimes you have like these major earthquakes, and maybe the building don't collapse, but it has like some damage that every time that you have a new event, it will have like a direct affectation. So it's only a small part. Like I think like these geometrical features, like the roofing connections are so important, but we also have to take it in account, at least as a part of all this set of parameters.
Okay, thank you, Adrià. So is there another comment or question? No? I ask for everybody, how often would you like to have a webinar like this? Because as I said at the beginning, we are planned to have 4, but we can manage to make some more if we see that there's interest. So, if we don't have, ¿cuándo será la próxima charla? Okay, la próxima, the next one, is planned to be in June, en junio. Okay, so if we don't have more questions or comments, I thanks again, Adrià, for your wonderful presentation. It was very, very interesting. And thanks everybody for coming and for attending. And remember that this presentation is going to be in our channel of ICOMOS, and maybe it's going to be with subtitles, I don't know. And at the end of the year, we want to make like a little booklet with the synthesis of the presentation of this series of webinars. So thank you again for coming and for attending.